What we're going to do first is to give an idea of fuel flow as an overview. Then we're going to go back through and go through each of the components. This is the best way to accomplish this, to accomplish everything we need to accomplish. Now, one of the things we like to stress is cleanliness. This system has very tight tolerances and does not tolerate contamination. First of all, let's look at the overall system. We have our hydraulically operated, electronically controlled injector. That's our little red system highlighted here. First of all, we get commands from the accelerator pedal that the motorist wants more torque. That's relayed to the powertrain control module, which uses communications lines and high-speed communications to signal the fuel injection control module, also known as the FICM. The FICM is going to use this information along with a crank and cam sensor to control the hydraulic oil pressure on this injector. We'll talk more about that as we go through it when we get to the end. All three of these systems are going to work together. We're going to have a lubrication system with our motor oil that's going to supply a reservoir for the high pressure oil pump, which is going to supply oil pressure to the top of the injectors. And then we're going to have a fuel supply coming into the middle of the injectors. We're going to use these two together to control fuel delivery. How do we get this done? Well, first of all, we start off with high pressure oil. And high pressure means it's anywhere from 500 to 4,000 psi. It's sitting in the top of the injectors, but the valving is closed, and we're going to talk in detail about the valving and in detail about how to look at this oil pressure without having to do anything other than look at a scan tool. This oil pressure is going to be controlled electronically by the fuel injection control module, or FICM. We've got two solenoids, one to open and one to close the oil flow. So we have high pressure oil there. We can control the flow of this oil or the application of this pressure to a piston. We're going to be moving a hydraulic piston electrically and using this high pressure oil. We're going to vary the electrical time. We're going to vary the amount of pressure to deliver varying amounts of fuel. Now, fuel comes in separately. It comes in at the bottom or in the middle. What is sitting down here is in a reservoir, so that when we apply hydraulic pressure, the piston pushes down and forces the fuel out the bottom. We get hydraulic multiplication we'll talk more about when we get into components. So these three systems are going to work together to give us our fuel injection. And we're going to be injecting fuel determined by the crank and cam sensor. So all these systems are going to work together. All three of them. We're going to turn it off and on electrically with the green. We're going to have high pressure oil that's varying in pressure in the purple. We've got a steady pressure of low pressure fuel coming in at the red. By using this together, and we're going to go through the components and show how to get multiplication hydraulically of this oil pressure to give us our 20,000 pounds or so of oil pressure. Three systems working together. If any one fails, they all fail. All three must be diagnosed and repaired, and we need to diagnose each one independently. What's happening at the FICM has very little to do with the high pressure oil. What's happening at high pressure oil has very little to do with the low pressure fuel supply. But all together, they're going to have to work together. Now, we're going to go through all these components in detail so that you know what data should look like in scan data and how you should take readings to identify specific operating conditions.